Hello students, I am explaining chapter number 3 atoms and molecules for class 9 science, and in this video I am going to explain the concept, that is what is an atom. Introduction of this chapter and laws of chemical combination already I have completed and uploaded all the videos on my channel. You can visit my channel to watch those all the videos. So let's start with today's concept, that is what is an atom. So, what is the definition of atom? An atom is the smallest building block of matter. If you imagine any matter, the smallest building block is atom. All substances are made up of tiny particles called atoms. And what is the size of atom? Atoms are very small in size, which cannot be seen by naked eyes. So they are called as tiny particles. So these all the points already we have studied in your earlier chapters. So now just a brief revision of those all the points. So what is the example? A mason uses bricks to build walls and buildings. So what is building? To construct a building, we require rooms. To construct a rooms, we require walls. And to construct a wall, we require a basic building block which is called as bricks. So these all rectangular bricks, if you connect together, if you join together, you will get a wall. And these walls are connected together to get a rooms, and rooms are connected together to get a building. Nothing but the building block or the basic unit to construct a building is bricks. Same way, there is one more example from the NCERT book, that is ant hills is made up of small grains of sand. You maybe have seen the ant hills. Somewhat it will be having like this shape. So this ant hill is made by ants, and to prepare this, ant will use the grains of sand. So as we have seen the sand grains, those will be very small. So these all the sand grains will be arranged one beside the other, and then by arranging this, we are going to get this ant hill. So to prepare this ant hill, what is the basic building block? It is nothing but the sand grain. Same way, similarly, all matter is made up of very tiny particles called atoms. So if you want to prepare any one sheet of a matter, then all the particles should be connected together. Then only we are going to get a matter. Now we will see what is the size of atom. As we have already discussed in our earlier chapter, atoms are very small in size, which cannot be seen by our naked eyes. So that only we are going to study here. Atoms are extremely small. They are much smaller than anything we can imagine or compare with. The meaning is we cannot imagine the size of atom. We cannot compare the size of atom with any other things. So it is so small. Millions of atoms together form a layer as thin as a sheet of paper. So as we have all have seen the sheet of paper is so thin, the width will be so thin. When you take millions of atoms together, then we can prepare a layer as a sheet of paper. So you can imagine the size of atoms now. Atoms cannot be seen with the naked eye. So these are some of the points where we have discussed what is the size of atoms. Now we can see the measurement here. Atomic radius is measured in nanometer. As I told you, atoms are so small, we cannot measure directly the size. So we can measure in terms of their radius. So radius means what? Radius is nothing but the distance between the center to the circumference. Atoms are imagined like a spherical particle, so they should have one center and the circumference. So the distance between the center and the circumference, this is called as radius. So this is called as atomic radius. So by measuring the atomic radius, we can imagine the size of the atoms. So see here, to measure this atomic radius, the unit we are going to use is nanometer. So what is 1 nanometer? 1 divided by 10 raised to 9 is nothing but 1 nanometer. Sorry, 1 divided by 10 raised to 9 meter is nothing but 1 nanometer. So 1 divided by 10 raised to 9 meter is nothing but 1 nanometer. Or we can write like this, if I take this 10 raised to 9 on the numerator side, it will become 10 raised to minus 9 meter, and this is nothing but 1 nanometer. Or we can write 1 meter is equals to 10 raised to 9 nanometer. How it will be? The 10 raised to 10 raised to 9 which is there on the denominator, we can shift it on the right hand side. So it becomes 10 raised to 9 nanometer, and that is nothing but is equals to 1 meter. I hope you are understanding. See here, if I write 1 divided by 10 raised to 9 here, and here if I write 1 nanometer, I can shift this on the other side. This is already on the denominator. If it shifts on the right hand side, it comes to numerator. So it becomes 1 meter is equals to 10 raised to 9 nanometer. So this is the conversion. Now I hope you will understand. So I'll repeat, 1 divided by 10 raised to 9 meter is nothing but 1 nanometer, or 1 meter is nothing but 10 raised to 9 nanometer. Now here in this table, we have some of the size of some example or the matter where we can compare. This is from the NCERT book itself. So see here relative sizes. In the first table, there is a radii in meter, and the second table, there is examples. So if you see atom of hydrogen, then its radii is 10 raised to minus 10. Molecule of water, that is H2O, the radii is 10 raised to minus 9 meter. Molecule of hemoglobin, which is nothing but a red color pigment present in the blood, it is 10 raised to minus 8 meter. Grain of sand, it is 10 raised to minus 4 meter. Ant 10 raised to minus 3 meter, and apple 10 raised to minus 1 meter. So these all are the radius of these all the examples. So now by seeing the values of their radii, you can imagine the size of each and every particle. So this was about size of atom. Now we'll see the next slide. Now we will start symbols of atoms of different elements. So how the atoms are represented or how the elements are represented in earlier days, that we are going to see on this slide. John Dalton was the first scientist to use symbols for elements in specific sense. When he used a symbol for an element, it is also represented one atom of that element. So John Dalton was the scientist who has explained the symbols of the elements. And while explaining whatever symbol he has given, it is considered as symbol of one atom of that element. So later John Jacob Berzelius suggested that symbols of elements should be made from one or two letters of their element's name. So after the discovery of John Dalton, then the scientist came, John Jacob Berzelius, and he told to write the symbols of elements, we can use one or two letters of their element name. So we'll explain this on this slide. Now see here, this is the table which I have taken from NCERT book. So for hydrogen, this was the symbol. For hydrogen element as well as hydrogen atom, this was the symbol. Carbon, it is just a circle with a grey color. For oxygen, it is just a circle. Phosphorus, you can see the symbol. Sulfur, this is the symbol. Iron, then this is copper, lead, silver, gold, platina, and this is mercury. So imagine oxygen, this, it is nothing but one atom of oxygen, or it is a symbol for oxygen element. If somebody says phosphorus, then the atom of the phosphorus will be shown like this. So this is the symbol of one atom of phosphorus as well as for whole phosphorus element. So these were the symbols used by John Dalton in the earlier days. And as I told, the scientist Jacob Berzelius suggested that we have to use either one or two letter of its name, and that method we will see on the next page. So now we are going to see modern day symbols of elements. In the beginning, names of elements were derived from the places where they were first found or from their colors. So in earlier days, how the names of the elements were derived? By using the place where we have found those elements or the color of the elements. Nowadays, International Union of Pure and Applied Chemistry, that is IUPAC, International Union of Pure and Applied Chemistry. So, approves the names of symbols of elements. So, this system has given the proper way of giving the name to a particular element. It consists of, see here, the symbols are usually formed from first one or two letters of their element English name. So if the element is having English name, from that English name, either we have to use the first letter or we can use the first two letters. The first letter is always written in capital and the second letter is in small. So if you are using first only one letter, it should be always capital. If you are using first two letters, then first should be capital, second should be small. For example, if I say hydrogen, we are using only one letter, that is H, and H is capital. For aluminium, we are using first two letters, that is A and L, and according to rule, A is capital, L is small. For cobalt, we are using first two letters C and O. C is capital, O is small. Some symbols are derived, are formed using another letter from the name, such as chlorine. So there are some of the elements where we are not using the starting two letters. We are using first letter and the second letter is in between the name. For example, you can see here chlorine. Chlorine is CHLORINE. First two letters are C and H, but we are not using C and H. We are going to use C and L. First letter is C and L we are using from the third place. So this is the method. So C should be capital, L should be small. Even for zinc, we are using Z, but we are not using I, we are going to use N. So the symbol is ZN, Z capital, N small. So these are some of the rules are used to give the symbols to the elements. Some symbols come from Latin names such as iron, that is Fe. Iron is the name of the element, but still we are writing the symbol as Fe. Why Fe? Because its Latin name is ferrum. Ferrum. From this ferrum, we have used starting two letters F and E. So F capital, E small. Then for sodium, we are using the symbol Na, and this comes from the Greek name that is natrium. From natrium, first two letters we have used, N is capital and A is small. There is one more symbol, one more element, that is potassium, Potassium, but we are using symbol K because K is coming from the Greek Latin name that is Kalium, Kalium. So we are using only one letter, that why K is capital. So for some of the elements we are using the letters from their Latin name. Majority of the elements we are using the letters from their English name. So remember this. And as I told, if you are using one letter, it should be always capital. If you are using two letters, first should be capital and second should be small. Now, this is the table from again NCERT book where they have given some of the symbols of elements. Symbols of some elements. First column is element, second column is symbol. So you can see here aluminium, argon, Ar, barium, that is Ba, boron is just B, bromine, Br. Remember, barium is Ba and bromine is Br. Should not get confused. Both start with B itself. For boron, it is just B. Calcium Ca, carbon is just C, chlorine Cl, and cobalt is Co. Now comes copper, Cu. So all here, all the elements were starting from the C. Next is fluorine, F. Gold, Au. See here, gold, Gold. But still the symbol is Au. So why Au? This Au is coming from the Latin name. The name is actually Latin name is aurum, that is Aurum. So this is the name. So we are going to use first two letters, that is A and U. So A should be capital, U should be small. Then comes hydrogen, iodine, iron, just now I told you, Fe, it is coming from ferrum, which is here. Then lead, that is Pb. For lead it is Lead, but still the symbol is Pb. Again it is from the Latin name, that is nothing but it's plumbum, that is Plum, plumbum. I'll write it here. This is for gold and here this is for lead. So you can see here plumbum. So that's why we are going to use P and B. That's why the symbol is P and B. Then the next one is magnesium Mg, neon is Ne, nitrogen N, oxygen O, potassium K, just now I told you from kalium, that is potassium K, silicon Si, silver is Ag, name is silver here, English name is silver, but this Ag is taken from the Latin name, that is argentum, argentum. I'll write it here. From argentum we have used Ag and this is for silver. So silver. Now the next is sodium, that is Na, it is from the natrium. Then sulfur is S, uranium is U, and zinc is Zn. So these are some of the symbols which is given in NCERT book. At least these common names we should know. So these are some of the elements whose symbol is given in NCERT book, and we should remember this. At least some of the common elements we should remember the symbols. So after this we are going to move with the next page. Now we are going to study atomic mass or mass of the atom. According to John Dalton, every element is made up of tiny particles called atoms, and each element has its own characteristic atomic mass. Scientists wanted to know how heavy atoms are, but it was very difficult to measure the mass of a single atom directly. So they compared the masses of atoms using compounds formed in a chemical reaction. So see here, according to John Dalton, Dalton has given the atomic theory, and in atomic theory he has told that matter is made up of particles, and these particles are very tiny, and every atom has a characteristic atomic mass in an element. So as they started finding the mass of these atoms, they saw that atoms are very tiny. They are so tiny that we cannot see by our naked eyes. So it was very difficult to measure their mass of a single atom directly. So what they did, they started comparing the masses of atoms using compounds formed in a chemical reaction. So whenever chemical reaction occurred, two or more elements come together, they will combine and they will give the compound. So in these compounds, they started comparing the masses of the atoms. For example, carbon monoxide, that is CO. Experimentally, it was found that 3 gram of carbon combines with 4 gram of oxygen to form carbon monoxide. I hope you're understanding. So when they saw the information of formation of carbon monoxide, experimentally they found that to prepare CO, one molecule of carbon monoxide, we require 3 gram of carbon and 4 gram of oxygen. This means that oxygen combines with 3/4 times of the mass of a carbon. So see what they have done. As the oxygen is 4 gram and carbon is 3 gram, they said that oxygen combines 3/4 times of the mass of carbon. If we take the mass of one carbon atom as 1 unit, then the oxygen mass becomes 3 by 4, and that is nothing but if we divide, we'll get 1.33 units. So I hope you're understanding. They found that oxygen combines with 3/4 times of the mass of carbon. And if we imagine the carbon mass is 1 unit, then 3 by 4, if we divide, we will get 1.33 units. That is the mass of oxygen. But such decimal numbers were inconvenient. Here we have got, for carbon we got 1 unit, but for oxygen we got 1.33 unit. And here we are getting the values in decimal, that is in points. It was very much inconvenient for the calculation and for the understanding. So scientists preferred whole number or number close to whole numbers. So scientists preferred to use whole numbers or the decimal number which is very close to the whole number. Then we'll see the next, that is earlier atomic mass unit. Initially, scientists use 1 by 16 of the mass of naturally occurring oxygen atom as the atomic mass unit. So in earlier days, for measuring this atomic mass unit, scientists were using 1 by 16, the mass of naturally occurring oxygen atom as the atomic mass unit. And this is why the reason is oxygen reacts with many elements. We can see the oxides of many elements in the nature. Means oxygen is able to react with many elements. It gave atomic masses close to the whole number. When they use this method, that is 1 by 16, the mass of naturally occurring oxygen as one atomic unit, they saw that they are getting the mass of the atoms which is very much close to whole number. It is not in decimal. It is not getting any problem to calculate. It is very much convenient. So they started using 1 by 16th as the atomic mass unit. But nowadays, we are using a different value for this atomic mass unit, and that is nothing but see here, present atomic mass unit, the symbol is used small u. In 1961, scientists choose the isotope of carbon 12. So as we know, carbon has three isotopes, 12, 13 and one more is 14. So out of these three, scientists use carbon 12 as the standard one. And nowadays also we are using the same unit. So what is the definition of this atomic mass unit? One atomic mass unit is 1 U. It is nothing but 1/12 mass of one carbon 12 atom. So what is one atomic mass unit? It is nothing but 1/12 of the mass of one carbon 12 atom. So all atomic masses are now compared with carbon 12. Earlier we were comparing with the oxygen, but nowadays in present situation we are comparing the atomic mass with 1/12 the mass of carbon 12. So we are using carbon 12 isotope of carbon for this atomic mass unit measurement. So you can see here atomic masses of few elements which is given in the NCERT book. Hydrogen atomic mass is 1, carbon is 12. Now these all atomic mass unit we have measured with the help of the present atomic mass unit method, that is by using carbon 12 isotope. So nitrogen is 14, oxygen 16, sodium 23, magnesium 24, sulfur 32, chlorine is 35.5 and calcium is 40. Chlorine is 35.5 because chlorine we have two isotopes, that is Cl35 and Cl37. So by measuring average atomic mass we are getting the mass of chlorine 35.5. So this is the table which is given in NCERT books where we have the mass of some common elements, and remember this is also very important, you should remember some of the masses of elements. So this was about atomic mass unit. Now we'll move to the next. Now comes next, that is relative atomic mass. The relative atomic mass of an element means the mass of its atom compared with 1/12 mass of one carbon atom. So what we are doing here, as I told earlier, to measure the mass of atoms, we are using carbon 12, isotope of carbon. So mass of the carbon is 12 as we all know, but We are comparing the mass of every atom with 1/12 the mass of carbon 12. So what is the meaning of this? Let me explain this with the help of example. So this is the example from NCERT book that is called fruit seller example. Imagine a fruit seller has no standard weight. He takes a watermelon and says its mass is 12. That is 12 fruit mass unit. Because it is a fruit, we are going to say now fruit mass unit, that is FMU. Then he cuts it into 12 pieces equally. So what he has done, we have imagined a fruit seller which don't have any standard unit. So he is going to take one watermelon, and that one watermelon he is going to cut into 12 pieces. So see here. So these are the 12 pieces of that watermelon. One piece becomes a standard unit. From these all, one piece is going to separate, and this we are going to keep as a standard unit. Now, other fruits are compared with this piece. Now this one is standard. Now this all the remaining piece and the remaining fruits here he is going to compare with this one unit. So same way here scientists are done. So what they have done, one carbon 12 atom is divided conceptually into 12 equal parts. So they have taken a carbon which is having 12 atomic mass, same like watermelon, and as watermelon is cut into 12 pieces, this carbon 12 is conceptually cut into 12 pieces. So we are getting 12 pieces of this carbon 12 like this, imagine. So here 6, 6, 12. So one part is called one atomic mass unit. So this one part is called one atomic mass unit. Like how we have kept one piece of this watermelon as standard, same like that one part of this carbon 12 is taken as one atomic mass unit. That is 1U. Masses of all atoms are compared or measured relative to this unit. So as the remaining fruits he has compared with this one standard piece. So here all the atoms masses are compared with this one piece of this carbon 12. And that is nothing but called as one atomic mass unit. So here by using this fruit seller example, we can explain how we are using 1/12 mass of carbon 12 to find atomic mass atomic mass of all the atoms. I hope you are understanding the explanation what I'm telling. So this is the method to find out the atomic mass unit. So this was the video where I have explained many concepts started from the atom. What is atom? We have seen the symbols of atom. We have seen the atomic mass of atom, and also we have understood the relative atomic mass. So I hope this video will give you a lot of information about this first chapter, first concept. Make a note of these all the notes, and if you like my video, share my videos with your friends, and if you're not yet subscribed my channel, please consider subscribing my channel. Thank you so much.